further ado, I want to introduce our first speaker. We have Wilfred Justin, who's the head of AI and machine learning evangelism at AWS. Justin, take it away here.
Good morning, everybody. Can you all hear me? Yep. So I'm Wilfred Justin from Amazon Web Services. I've been with Amazon for a long time. This is my 8th year. I joined Amazon as an architect and then did a bunch of different things, right? I used to work with technology companies and help them to build their entire stack on AWS. And currently, I'm just leading a team of AI and ML experts and tend to focus on technology companies that build solutions based on machine learning or deep learning, right? So that is about me. And with me, I have Raj Karyala. He is going to give you a lot of demos later part of the presentation. We also have a subject matter expert here, Balaji. So he's here, so he can answer all the questions. So we all know that artificial intelligence is literally transforming the world we live in, right? By driving beneficial outcomes and generating positive values across many industries, right? Starting from defense, finance, robotics, space research, manufacturing, and so on, right? But today we are just focused on healthcare. So I'm just going to talk about how AWS and artificial intelligence is driving beneficial outcomes in this field of healthcare and life sciences, right? So the talk is around 60 minutes, 30 minutes, probably 20, 25 minutes. I'm going to talk about 20 minutes. I'm going to talk about interesting use cases and technology companies and how they are disrupting this industry using AI and AWS. And then probably we'll jump into the stack. And to be honest with you, we want to really dive deeper. So we are going to just give you 3 demos. But within 60 minutes, we can only cover to a certain extent. So if you're interested, we do a lot of other things, including deep dive sessions, hands-on workshops on any topic you might be interested in. So with that said, let's get started. So I'm just going to give you a couple of interesting case studies. So how many of you know about a company called Babylon? Very good. So Babylon's mission is they want to provide affordable healthcare to every citizen in the world, irrespective of his geographical location or financial status, right? So this guy could be in Africa or in UK, but they still want to have access to good healthcare. So that is a perfect use case for something like artificial intelligence, right? So the doctors there built a company completely based on AI, and they built a stack on artificial intelligence that runs on AWS. So what it means is, if you're having any symptoms or diseases, you don't need to be part of a healthcare plan, or you might be in a remote location where you may not have access to it. All you have to do is open an app and start interacting with the app, right? The app is going to ask you questions, you're going to answer. But if you think about it, it is definitely beyond ASR and NLP, because based on your answers, it can frame the next question. But it is pretty much building a knowledge base of your background, your context, and your symptoms. But it also has a knowledge base of probably 513 million knowledge streams. They have the largest knowledge base. So based on interaction, they can use predictive analytics, they can use deep learning and machine learning, and they can exactly diagnose what is happening to you, and they can also suggest kind of medicines and other things, right? So the point of the app or the point of the company is not to definitely replace doctors, but to initially provide all kinds of triage services and virtual clinical consulting services and so on. But beyond a certain point, if you want to talk to an actual doctor, the app can also connect you to the appropriate doctor based on various factors, and they also use machine learning for that. So this is one small example of how AI is transforming, right? The other company is really interesting, Apexio. I don't know how to pronounce it, but it is API plus X plus IO, right? That's why the company is called Apexio. So what they do is, the value prop of the company is 2 things, right? We come from public sector, so I just want to talk about CMS and Medicare and Medicaid. So there are healthcare plans like Medicare and Medicaid, and there are healthcare providers like doctors and physicians and so on, right? So when a healthcare provider accepts a Medicare plan like Medicaid and Medicaid, they want to get reimbursed. So how do they get reimbursed? It's really based on outdated technologies, because I know it personally. So they have to do different kinds of codes called ICD codes, right? I hope a couple of you guys are physicians here. So they submit, end of the day, when they want to get reimbursed, they send a big summary of those reports, right? Which is nothing but ICD codes. So when they do that, they have to be absolutely compliant, right? They have to make sure that the healthcare providers are not doing something, and they should not be flagged for Medicare frauds. So it is a really intensive task, right? They usually, big companies like Cigna, Magna, and Blue Cross Blue Shield, they literally outsource this effort to third-party companies, right? So that they review the patient charts, they go through the ICD codes because it is manually entered. People might enter a wrong code for a wrong diagnosis, or sometimes the codes get missed, right? So because of that, a lot of follow-up questions happen, and they have to provide a lot of supportive documents. So the point being, lots and lots of time is being wasted on providing this kind of data points. So this is where Apexio uses machine learning so that it automates everything, right? It automates the workflow. It can check for all the ICD codes so that you don't need to spend a lot of months or weeks, and you don't need to outsource it. But the value prop is it is helping all the healthcare companies to be compliant, and they can get reimbursed. But if you look at the bigger picture, for CMS, they'll be able to find out, hey, how many people in Virginia is going to suffer from flu this year who are above the age of 65, right? If you ask that kind of query today, the answer is not accurate because they're all still based on the outdated ICD codes, and there is usually a time lag between patient being treated and the reports being generated and reported to CMS, right? So using artificial intelligence and machine learning, they not only take these ICD codes, but they have a 360 view of the patients, and they can provide this kind of insights based on which people can make well-informed decisions, right? Especially when it comes to assessing the risk of a patient of a particular population, right? So we can move on to the next case study. Numerate is again a technology company, and they are literally disrupting the process of drug discovery, right? So I think, again, a lot of people are here, physicians and researchers. To come up with a drug, it takes a lot of time. It takes a decade and billions of dollars, right? Because it involves both R&D, clinical trials, and finally FDA approval, right? So what Numerate does is, I spoke with one of the startups which works very closely with Numerate, but what Numerate does is they do what is known as molecular structure analysis, right? And molecular dynamic simulations, right? So in order to do that, think about it, right? In order to identify the right molecular structure, you have to probably process billions of molecules, and out of billions of molecules, probably 100 molecules are going to be candidates for that. So what it means from a technology perspective, you have to process tens and thousands of molecular structure in real time to find out that one molecule, right? So we can go on and on, but this is where you need very powerful computing like HPC. So that's what Numerate does, and they have built their own custom computing model framework called Numatics that runs on AWS, right? Moving on, DNA Nexus, again, enabling genomics and precision medicine through high-performance computing, right? Precision medicine, again, my background is computer science, and my passion is healthcare. And if you think about precision medicine, absolutely, genome sequencing and genome analytics is playing a big role, right? What was not possible a decade back, right? It used to take probably 10 years to sequence a genome, but because of the next generation sequencing techniques and powerful cloud computing platform like AWS, it can be done less than a day, right, for a few $100s. But we're not talking about genome sequencing here. While you're doing genome sequencing, it generates tons of data, right? And that data needs to be shared with doctors, physicians, clinicians, and researchers so that they can use the data to research and come up with medications, right? So this is where you have to have petabytes of scale of data for storing the data, and you have to have large clusters. I'm talking about 50,000 node clusters. So again, this is a good segue, right? What was like 10 years back, all the drug DNA sequencing company, if they want to do this kind of complex sequencing, they usually went with a multi-million-dollar or $20 million hardware, and they run the sequencing a couple of times and they're done, right? Whereas here, with cloud computing, what you can do is you can literally virtually build a computer, supercomputer that doesn't exist. So DNA Nexus builds huge clusters, like 50,000 node cluster, 70,000 node cluster with hundreds and thousands of petaflops of operation, so that you can do this kind of whatever it is, molecular analysis or Monte Carlo simulations or whatever it is. You can do it a couple of times a day, and then once you're done, you can dismantle the server, release the resources, and you can stop paying for it, right? So it is really powerful, and that's why it is disrupting it. And DNA Nexus is a great company, and if you think about most of the pharmaceutical companies, they use DNA Nexus as a genetic analytics platform. And finally, for the final use case, we can talk about Celgene. Anybody from Celgene here? Okay. So you can talk about the use case. So Celgene is an amazing company that is trying to find drugs for cancer and stuff like that, right? So the sad fact is, still we suffer from diseases like dementia, Alzheimer's, and cancer, and we are still on a journey to find medicine for that, right? So Celgene is trying to do a lot of research on cancer research. And again, coming back to artificial intelligence and deep learning, right? So in order to find during cancer research, again, as I said for Numerate, you have to literally process tens and thousands of cells in real time, image process those cells, so that you can differentiate between the real cells and the cancer cells, right? The traditional algorithms and techniques didn't scale. Number one, it didn't scale. Not only that, they didn't scale, they didn't provide precise results. So this is where deep learning networks come into play, right? Using artificial neural networks, you can literally in real time process tens and thousands of cells and find out the pattern, differentiate between regular versus cancer cells. So one example is Celgene is doing that, but the point is they use the other use case that they're doing is probably toxicology prediction. So what it means is, again, clinical trials take a lot of time. As I said, it takes 10 years to release a drug. So most of that time is spent on clinical trials, right? So toxicology prediction is a discipline where you can really study the impact of the medicine, impact of the potential drug, without even applying to the actual test agents. It could be humans or it could be animals, right? So Celgene uses Apache MXNet as a framework, and they use Amazon SageMaker as a platform to do that, right? So we can go on. And again, one disclaimer is I just chose 5 of the many use cases available on website. It is not based on any criteria. So feel free to go to Amazon website and look for more case studies on that, right? The point being, these are the use cases. These powerful stories tell you how AI is literally transforming and disrupting this healthcare and life sciences industry. It could be in expediting the research, or in clinical trials, or in drug discovery. And I believe that the trend is going to accelerate. And if at all we find a drug for deadly diseases, I think AI would play a very significant role in it. So the question is, why it didn't happen in 1950s, right? Because we had the first wave of AI and deep learning in 1950s, and probably even the neural networks existed for decades. And I'm going to quickly cover that to get into the Amazon machine learning stack. Because back then we had a lot of blockers, and today we have a lot of enablers, right? One is big data. I hope guys are data scientists and deal with large sets of data. 10 years back, I used to work for Oracle, and big data was the biggest topic there, because we really had challenges in solving the big data problems, right? We can talk about 4 Vs or 6 Vs or 8 Vs, but now it is not, right? You can really ingest large volumes of data in real time as well as in batch mode, right? And not only you can ingest, you can store them without worrying about durability, availability, security, compliance, and HIPAA, and so on, right? You can do that. So you can process the data, you can store the data, you can ingest the data, and you can also process the data, right? Both in real time as well as in batch mode, depending on the use case, whether it's Hadoop or Spark and so on, right? And you can then derive valuable insights to it. And the point being, for machine learning, right, especially if you use deep learning networks, they are really hungry for large volumes of data. So now we have taken care of it. You can feed large volumes of curated data to this machine learning algorithm, right? The second innovation or driver is hardware, and probably I don't need to explain GPUs. GPUs are meant for massively parallel algorithms, and that's what deep learning is all about, right? It's massively parallel, and you can feed it into GPUs, and probably we are going to show a couple of demos using GPUs. And finally, that's where I want to come, the innovation that is happening at the software level, right? And probably I think you guys are using different kinds of frameworks like TensorFlow or PyTorch or Apache MXNet. So a lot of innovation is happening, which is making building AI applications much, much easier. And software innovation, when I talk about software innovation, absolutely cloud computing comes into play, right? So say, for example, you can instantiate a very powerful server with 8 GPUs and 96 vCPUs using a simple API. And because of that software innovation, which includes cloud computing like AWS, people are able to build artificial intelligence applications really easy. And we can dive into that, right? So that's our goal. We want to make machine learning really simple, and we want to put the machine learning in the hands of every single developer. So what it means is, whether you're a data scientist or an application developer or an expert practitioner, you should be able to build sophisticated AI-based application. It could be NLP, it could be ASR, or it could be you guys building a custom deep learning model. It should make it really simple. So how do we realize our mission, or how do we achieve this? Using our stack. And that's what we are going to spend most of our time here, right? So before I begin, how many of you use AWS as a cloud computing platform? Okay, probably 80%. How many of you out of those 80% uses Amazon machine learning stack? Okay, literally a couple of people, right? So that's the goal, right? We want to educate you, and we can do only, I think we can do only a certain amount of justice in 40 minutes, but the point of this presentation and demo is you have to ask a lot of questions, challenging questions. Probably we may not be able to answer all the questions, but we'll be in the booth, and we can find out ways through which we can really help you. So coming to this machine learning stack, we have 3 different layers. And the way I want to do this is through a lot of demos, and that's where Raj is going to come in, but I'm going to talk about the layers first. So the bottommost layer is meant for, it is called machine learning frameworks and infrastructure. It is meant for expert machine learning practitioners. So what it means, these practitioners have used different kind of frameworks like TensorFlow or Apache MXNet or whatever it is, right? And you're not only comfortable, you know how to optimize it. You know how to do hyperparameter tuning and all those good stuff, right? And also you need to know how to optimize the machine learning algorithms. There are multiple algorithms there. You should know how to optimize that. So for those of the guys who are expert in that, they say that, hey, we know everything. And at that point, they need only 3 things, right? They need performance, they need flexibility, and they need cost saving, right? And that's what we exactly provide at that layer. So I'll talk about flexibility first, right? So this is a slight differentiator between AWS and other cloud providers. So we are agnostic when it comes to frameworks. We support all the open source frameworks, including, I don't want to keep repeating myself, but it is TensorFlow, Apache, MXNet, PyTorch, and Cafe2, and all those good stuff, right? So we not only support that, we optimize it, right? We optimize it on multiple platforms, right? We optimize it on SageMaker so that it can run 10 times faster, but we also have a lot of deep learning armies that is available for you to consume because you're an expert practitioner, you're not looking into an abstraction layer, you just want to deploy it and you want to procure it and deploy it in your virtual data center, which is a VPC, right? So we do that. So that's the point when it comes to flexibility, but when it comes to performance, you need really powerful machines, and I think I already touched on the topic. We are going to talk about GPUs and FGPAs. So we have a couple of instances like G2 instances and P3DNs, which has a lot of GPUs, right? We work with NVIDIA, and we are one of the great partners, and we virtualize it, right? So to drive the point, I was just talking to a startup's CTO, and he was asking questions, right? Because he's using a lot of frameworks, but he wants to use AWS, and he was asking questions like, hey, what kind of service you have? So to just give you an example, P3DN, 24 extra large, or 16, I'm not sure. The beauty of it, you can instantiate that kind of powerful instance within one API. And you can build clusters of those instances and can run massively parallel jobs. That instance comes with 8 GPUs, Tesla, NVIDIA chips, and it comes with 96 virtual CPUs, Skylake processors. Probably it comes with 256 gig of GPU memory, close to 1 terabyte of regular memory, and it comes with 100 megabits per second of networking, right? So that's to drive the point, right? So it is really powerful. You can instantiate the server, and you can instantiate a whole bunch of servers, do the job, and do it. So that is very appealing for expert practitioners. Now, coming to elastic inference, coming to cost optimization, right? So when those expert practitioners want to build really powerful and flexible application, they are also conscious about the cost. This is where I'm really interested, and probably next demo we can build something on Amazon Elastic Inference. The point of Amazon Elastic Inference is a lot of people use GPUs for machine learning and deep learning models, right? But they generally select a generic purpose GPU, which is very powerful for both training, tuning, and deploying. But if you think about GPUs, they're meant for massively parallel algorithms, right? And that happens during training and building the model and tuning, but not during the process of inference. When it is already in production, when it is generating inferences, it is usually single-threaded. So you usually don't use the full use of GPU, and a lot of GPU time is wasted, which translates into cost. So that's where Amazon came up with 2 years back what is known as Amazon Elastic Inference. So from a 10,000 feet, what it means is you can burst, right? For a particular application, you can use appropriate amount of CPU, virtual CPU, and appropriate amount of GPU that is needed so that you can optimize the cost of your machine learning model, right? And there are a lot of interesting third-party studies where big companies and enterprises have saved close to 75% just because of using Amazon Elastic Inference. So I just want to briefly touch it, and we can cover it later after this presentation. So coming back, on top of it, right? On top of it, we talk about machine learning services, which is our SageMaker. This is where we are going to spend a lot of time, not today, but in general, we spend, when we talk with customers, especially technology companies, we spend a lot of time on SageMaker because most of the companies, they want to abstract all the complexities of infrastructure dealing with clusters and storage, but they are all building their own custom models, right? So they want to build a custom model. So SageMaker is a machine learning service which abstracts the complexity of you building a custom model, right? You're still going to build a custom model, you're going to choose the algorithm framework, but it abstracts it and makes it really simple by taking care of all the infrastructure complexities that come with it. So we can spend a lot of time on that, but let's start with that, right? So maybe I'm not going to follow this slide. Oh boy, a lot of animations. So first of all, you need a lot of data, right? So how do you, I think 80% of the people use Amazon machine learning stack, Amazon platform, and very few of you use Amazon machine learning stack, right? But the point is, before you train the model, before you choose the algorithm, you have to have lots and lots of data, right? You have to curate the data, probably label the data, but you have to download the data and you have to have access to the data, right? So I'm not going to talk about S3 and all the great attributes of S3, and probably everybody knows about S3 and all those good stuff, right? It's an object store, it's massively scalable and all those good stuff. So you put the data in S3 and SageMaker can seamlessly download it from S3. But what happens typically when you start a project, storage is not on S3, it might be scattered across multiple services, and probably this is where you can relate to it since you're using Amazon Web Services. It could be in DynamoDB, it could be in Redshift, it could be in RDS. So we have a lot of other services, which is part of our broader stack. We can talk about big data services, we can talk about Glue, where you can ingest or extract, transform, and load the data. You can do the curation, you can do all the good stuff and load it into S3. And once it is in S3, you can download it into SageMaker. So that is the data. And then you choose the algorithm, right? You have the data. Now you have to have the algorithm. I think I already mentioned it. It comes with 16 or 17 different algorithms, right? So all the machine learning algorithms are highly optimized to run on SageMaker, 10 times faster. How? Raj is going to explain how it is optimized, but it is optimized to run 10 times faster on SageMaker, and it also comes with all kinds of frameworks, which is also optimized to run twice faster on SageMaker. So you have the algorithm, you have the data, and then the next step is you have to train the data. So I'm going to, I didn't do the slide, so I'm not into animations. So this is what we talked about, right? We talked about all these algorithms come out of the box, and it is optimized. And we have a separate presentation. When we come to one-day training or two-day training, we can dive into each algorithm and the use cases, and we can talk about it. So training is literally one-click training. You can just click and start the training of the model, right? And when you do this training, this is where it can become tricky. Probably when you train and tune the model, probably you have to scale the storage to petabytes, and you have to build humongous size of clusters. So if you have to do it without an abstraction service, you have to do all the infrastructure work by yourself, right? When you use an abstraction service like SageMaker, it takes care of the scaling of the servers, clusters, as well as the storage behind the scenes for you so that you can just focus on model training, right? And again, I'm covering it from a high level. We are going to give demos, and we can dive deep in. We can dive deeper on the both, AWS both. And then once you train the model, tune the model, you have to deploy it. So this is where probably you guys are using AWS. When you're deploying your model into production, this is where you have to absolutely implement all the best practices of the cloud. You should adhere to the well-architected framework, which talks about resiliency, scalability, and security, and so on, right? So say, for example, if you want to deploy it on a different instance, and if you want to deploy it on multiple instances, and if you want to deploy it across multiple AZs, in SageMaker, you can all declare what you want to do, and we are going to exactly show how it is being done on the demo. So that's the value prop of the platform, right? To sum it up, it is an abstraction service, which makes building a custom model much, much easier. What kind of time? 20 minutes? Okay. So with that said, we can, instead of me talking, we can probably, I'm going to touch upon this. This is all, it's a value prop. I think you technical guys can get it. It reduces cost. I said elastic inferences is one of the mechanisms to reduce the cost, right? By using GPUs appropriately. I didn't talk about ground truth, which is not probably, if you want, we can talk in the booth. Because for supervised learning, you have to label the data. And in order to label the data, usually human factor is involved. But that's the whole point of machine learning, right? So once you start labeling X amount of data, then the machine can pick it up. We can apply machine learning algorithms so that you can automate the labeling process, right? So you can save 70% there. I talked about 2x performance increase in the frameworks like TensorFlow and other things. I talked about 10x performance for algorithms. And cost reduction, we talked about it, right? So I think you understand the concept of SageMaker from a high level, at least from a 10,000 feet. So I think I did a decent job of explaining things. So the next step is the best way to explain it is to do it. And that's where I'm going to invite Raj, who has a lot of experience in machine learning across AWS and Google. So he's going to spend first demos about SageMaker.
Yes. Hi guys. My name is Raj Karyala. I work with Wilfred. He's my manager. So if I mess something up, it's his fault, right? With that said, we talked about SageMaker. How many of you here have used Jupyter notebooks before? It's quite a few people, right? How many of you have actually deployed a model to production from Jupyter Notebook? Like, it has to be all the way from training the model to deploying it to production. How many of you have done it in Jupyter Notebooks? A couple of you guys. Okay. So that's what, when I was doing data science several years ago, Jupyter Notebooks were very limited. We only used to do like basic POCs and stuff. You couldn't go this far and deploy something to a production. With AWS SageMaker, that's made possible here. If you look at a couple of things, so the data for this, what we're doing here is we're taking a bunch of 47 gigs of X-ray data that's publicly available, that's labeled across 14 different conditions of chest X-rays. Like, we're running that through a Amazon SageMaker image classification, multi-class image classification model, and we're deploying it to production as an inference endpoint, and we're actually going to test a couple of images to see what the results are and how does it compare to reality. Now, as a caveat, this wasn't super well tuned. Like, I ran it 2 days ago, downloaded all the data. It took me about a day to put it all together. So it's pretty fast, but it is not hyper well tuned to where the disease predictions will be completely accurate. So bear with me on that. We could go around and show you how to do and improve that. So one thing here is, this is my training area, right? So essentially, I'm importing SageMaker library, and I'm setting where my data is and what kind of instance I want to train it on. Wilfred talked about P3 instances. That's what we're using in this particular case. We're using a P3 16x large with 8 GPUs and 128 megabytes of GPU memory. We're using SageMaker. All the data is sitting in a bucket here in S3. So this is, as you can see, I named it appropriately, so you know that for a fact that I put this together for just this reason, right? This particular conference. So all of my images are here. There's about 47 gigs of them, and that's what this particular model is referencing here, right? So when I train this, it takes about 2 hours to train. So how do I know that? So I can go to SageMaker and go to my training jobs here. It's completed 2 of them. I ran them back to back by tuning hyperparameters a little bit so I can get better results. And that's all the time I had. So 2 hours, went through 47 gigs of data for training and completed the training process. And then we have deployment is just that one step. I just said deploy whatever I trained to an MLM4 X large instance. Obviously, I don't need a GPU for inference here, so I'm using a smaller instance, but it's a bigger CPU instance regardless. And then I'm here, what we're doing in the next stage is I'm showing you, we can run this live here, right? So that's the image. That's the label of the image that I'm highlighting here. So why did I pick this? Actually, I have a test set here at the bottom, and I have conditions what I'm supposed to get when I run this. For this particular image, the disease conditions should be infiltration. And if I continue to run this, I get two conditions with a high probability. Infiltration is one of them, right? So I can easily pick a different image just so I didn't make this up, right? Let's go try that one. I don't know what the result is going to be, but we give it a try. So it's showing emphysema, infiltration, nodule. If I go back to the result, emphysema is the condition that was supposed to be should be predicted for that. So not only is predicting just one condition that maybe a radiologist. How many of you here are radiologists? Anybody? No? Okay, good. So a radiologist might say just one condition, but as you train machine learning models, they get smart enough to kind of identify other things that are probably present, right? You know, a radiologist might conclusively say, look, that's the major thing, that's what we need to address today, but a machine learning model will give you more probabilities, 14 probabilities for 14 different conditions, and in ways, it should definitely be verified by a radiologist after, because these are humans, and we shouldn't completely act on machine learning alone. But however, it gives you a higher probability of detecting other conditions that you may otherwise not focus on, right? So to summarize here, I took about half of my Saturday, instead of playing with my kid, I spent on this. And in the Saturday, I was able to download the image, pre-process it, upload it to my S3 bucket, build a model, train it, and get to this level of accuracy with it, with a public data set, right? And that's only one day, and I'm not even I'm full developer. I'm in business development with Wilfred here. So imagine what a team of developers can do with that sort of compute power, right? If you have any more questions on this, and we used the image classification built-in algorithm. We didn't go build an algorithm from scratch for this. We just used one that's available on Amazon directly. So if you have any questions on what other things you could do using SageMaker and predicting things, come talk to us at the booth. We'll talk more about it.
What is it? How do I go back?
Yeah, I can see that. That's what we just showed you. So those are some of the specs of what we just demoed here.
So I want to go really fast because the best way to understand AI services is through demos, and I'm going to give a lot of time to Raj to finish that, right? So the top layer of the stack is called AI services because we talked about machine learning experts, and Raj and myself talked about SageMaker, but there might be a lot of application developers here who may not have deep learning expertise, or there may not be a need for building a custom model, right? So if you're doing, say, for example, if you're building an ASR or NLP-based application, the point is you should be able to invoke an API, send an input to it, and you should be getting a result, right? So that's where we build AI services. You can read it, and you can understand what it does, right? So we have a lot of services when it comes to language, like ASR, NLP, translate, and transcribe. We have vision services, which can, the name implies, right, recognition. It can understand the text. It can also understand video streams, and it can process a lot of things about that, right? So instead of talking about the definitions, probably Raj is going to demonstrate, but I'm going to give you powerful examples, right? Because think about it, right? If you think about speech and language, let's talk about language. Translate, transcribe, and comprehend. I work with a technology partner in 2013, and what they do is, this is the beauty, right? We are slightly digressing, but the point being, this is where AI is really powerful, and what was not possible probably 8 years back or 10 years back is being made possible, right? So in this small example to demonstrate what is language services, I worked with one of the partners. I managed them for 3 years, helped them to build everything. They fight child trafficking, right? They fight child trafficking through a number of means, right? And they also work with a nonprofit organization, but the point being, they scan through millions of ads on the web, So it is not just converting your image to text, but it is also understanding. It is comprehending. It can understand the ad as a human would, which means that it can understand the figure of speech, the intent, and the sentiment analysis. So even if it is not explicitly stated, if it is even implied, it knows that that ad is trying to target children for trafficking, and it can work with local law enforcement agencies to inform and prevent it from happening, right? So we can talk about vision in the similar way. We have a lot of interesting studies where you can literally stream. You can take a stream of like camera feed from a traffic camera and you can match it with a photograph of a victim in real time. So these are the things which was not possible probably 10 years back because of the power of the GPUs and frameworks and cloud computing platform like Amazon. We can do it. So, and since we are focused on comprehend, I think Raj is going to focus and show that comprehend service, right? The service is given a text or anything, right? There are a lot of PHI data, there is a lot of diagnosis data, and a lot of patient information data, right? So it can go through the text and it can understand not only it can understand the PHI data, it can also show you the relationship between the diagnosis and what the doctor has stated, right? Diseases. It is powerful. We are still working on it. There's a lot of scope to improve it, but it's really powerful. So that's the point of AI services, right? You don't need to have the background. You just invoke an API endpoint. You send the input, and you're going to get the output. That is all about AI services. And to drive the message, Raj is going to take a lot of is going to show you a number of demos.
It's not. Yeah, let me see. There we go. All right. So actually, let's go back to that slideshow real quick so I can. So the context here is we'll see a few demos here. One of them will be to show how we can redact. So say you have an X-ray image, and that usually has your name, date of birth, age, and everything. And you might want to share that with somebody else, and the patient, you might not have patient's permission to share it for whatever reasons. Or you might want to put it out there for research and development, or maybe you want to publish a conference paper. Whatever the use case may be, you want to redact that information, right? And you might have tons of those. If, for example, for the data set I got, there was 47 gigs of data, and all of those, they had to completely remove that belt of personal information. However, I could maybe share the age of the person because that might be appropriate for the diagnosis of it. So in any of those scenarios, imagine having a storage area like your box or drive or Google Drive or something like that. In this case, it's an S3 bucket, and creating a separate S3 bucket and giving somebody access to that, and they can only see these X-rays that are redacted. And to build that, to show that end-to-end process, we'll go back to the S3 console here. So I have an input bucket here. This might be me. I might have complete access to things. And if I go back to this is the image. It's got name on it, right? It's got age and account number, date of birth. These are all sensitive information for a person. These are not real people, yes. So in this scenario, I'm going to go ahead and upload it to my bucket, right? And the other bucket could be Wilfred's bucket. And the underscore 90 at the end of that name means I want 90% confidence that something is a PII for it to redact it. I could pass that information any number of ways. For the sake of the demo, I chose to pass it in the file name here. So what the application does is there's a serverless compute platform we have called Lambda. What Lambda does is it's going to take the file name, split the file name, and get the 90 off of it, and pass it as a parameter to Amazon Recognition. Recognition is our image recognition service that Wilfred just showed at the top, and actually can detect text, objects, and other things. So if I go to my redacted bucket, which is empty here, I should see an image here. If I download this piece, since I set my confidence to very high, 90%, it only redacted the account number. That's what it thought. It wanted to say, hey, 90% confident that this should be some important number, so I'm gonna redact it. If I go back and do the same thing with $70, in about input. So if I go back and take a look at this one now, that's what it should look like. I don't know what happened there, but that's what it should look like. So it should have redacted all of that information. So most of the time these things work very well, except for when you're demoing it to people, right? So.
And you've written the logic based on the file name.
Right,
So
right.
70, it does 70% redaction.
Right. Next demo we're going to look at is the transcription piece. So actually, like the Amazon Comprehend service, which is our text service. And you can see there's already a bunch of text copied here. It actually shows you, highlights what a symptom is, what a medication is, and how much of the medication it's being taken, and how is it related to how is the dosage related to the medical the medicine and all that stuff. It highlights all of these entities, right? This way you can actually then store this metadata into a database of some kind, and then use that to search for certain situations, right? So it's nice and well for one document to look at it like this on the UI. However, if you want to look at thousands of documents, if you want to search thousands of documents, you can't do this as a practical thing. So how do we achieve that sort of stuff? So if we have transcriptions bucket here, I uploaded about 20 of them. We can throw in a couple more out of here. So what happens is after these are uploaded, it gets processed and puts into a Elasticsearch, which is a textual search, open source textual search software service that you could actually get on Amazon as Amazon Elasticsearch. And you can go in here, and I can type in, for example, I typed in the condition cancer. It brought me all the patient records that have cancer mentioned in it. I could change that to pain, right? It brought me all of this. So now imagine if you have thousands or hundreds of thousands of documents like this, and you want to search it, and you want to search by a condition or a dosage or a medication or whatever it is, you could send that stuff through our Lambda, or Amazon Comprehend Medical, take that metadata, put it into a database, or Elasticsearch in this case that I'm using, and you can search for whatever conditions you're looking for. This is an easier way to search for things versus having to go and upload each document or go through each document and look for it, right? So this is the demo for Amazon Comprehend Medical. The services involved here are S3, which is our storage platform, Lambda, which is where the Comprehend Medical is run from, and then you can also see Kibana here, which is a UI for visualizing whatever is in Elasticsearch. So it's called Elk Stack, if some of you who might know about it. Usually used for log analysis, but here we're using it for this particular purpose. And the third one I wanted to show you was our transcription service. here. So here, we can go, like I'll play a small bit of audio here from this file. Again, this is not a real person, so.
She again reiterates that there's no knowledge of previous compression fracture prior to the X-ray done recently. Pain is present but controlled. She denies any chills or sweats. Her cough seems to be a bit better.
So I take that same file, right, and go and create a job here. And I'll grab that from my previous job that I ran here. Oh, wow. Mood lighting. It's a WAV file. And then I have a medical terms vocabulary, because when doctors talk, normal human beings don't understand that language, right? You know, it's kind of hard for, even the names of the medications are like, they make it so hard to pronounce or even like say it right. So we have to inject a custom vocabulary to let the software know, to let the service know that these kind of words, you could expect these kinds of words in this audio. So once you do that, while we're waiting for it, that's the same exact file I ran, and this is the output from that, right? So it's pretty spot on. We listened to about 30 seconds of it. It's pretty spot on for most part, right? There is she denies any chills has been transcribed as children there, but outside of that, like it identified the medications, it identified pain control, seizure activity, sweats and cough, breathing treatments. All of those are very well identified. So obviously, when we speak and when we record something in a video, we have accents, we have stemming and all of these things that we don't record things very well. Sometimes we might click on a button, we might move a piece of paper that could blur some of the audio. So right. So it's very hard to kind of, even as a person, to listen to certain audios and say what the person was saying. So there are certain small exceptions, but for most part, this has done a pretty good job of identifying vitamin D deficiency, supplement, diabetes, the disease condition, something called CA53, I don't know what that is, JVD. All of these are like very well identified. I listened to the whole audio, whole transcription myself, and except for the children part, it done pretty good for most part, right? And that might be 99% accurate, and that's pretty good. Like if you were thinking about thousands of audio files that have been recorded and stored somewhere for years, and you're trying to transcribe to take actionable insights, right? To get actionable insights, you have to have data. Sometimes this data just sits collecting dust in some warehouse. So being able to do something like this and being able to go back in time to examine some of those findings is very valuable, service to have, right? With that, I'll give back to Wilfred here.
You're going to conclude in 5 minutes. Should be the last slide. Yeah, I'll take it. So probably I think you guys got the point, and if you have any questions, you can ask us in the booth, right? So that is for application developers without any background, right? So Raj put all these demos. Whenever we go for industry conferences, we try to build custom demos based on the conference theme. So Raj probably his background is development, but he's not a developer at Amazon, but he was able to put together all these demos within one day, right? Half a day. Couple of days. So the point being, it is really simple, and that's how AWS is trying to make it really simple and easy for people to build applications. So to summarize, why AWS for AML? You can probably, if you have listened to my talk, I don't need to repeat it. We have the broadest and deepest set of AI services, whether you're an expert practitioner or building your own custom model or an application developer, we have that. and support for multiple frameworks. I don't want to repeat it. Multiple times we have repeated it. Accelerate your adoption of machine learning using SageMaker, right? So probably you got a glimpse of SageMaker, but you have to really work on it to understand and appreciate the power of SageMaker. So to give you an example, I didn't want to quote a company, but what took a company 6 months, right? They took financial data of all the customers for a year, and they wanted to do some kind of cost optimization and fraud detection model, right? They want to alert the customers. So what it took 6 months prior to SageMaker, that time, modeling time and tuning time was reduced to a week. And if you want, it's a public reference, it is Intuit, right? So that is one. And optimize for machine learning. We want to drive that point. All the frameworks are optimized to run twice faster, and algorithms are optimized to run 10 times faster. I was hoping that you're going to ask questions on how it is being done, but we can talk about it in the booth. And reduce cost, two things, right? Elastic inference, optimum use of GPU. I think we talked about it. And second is ground truth, which we didn't cover. It is meant for supervised learning. We can do that. So the point being, because of this reason, right, and beyond that, I strongly believe that machine learning stack is part of Amazon compute platform, right? Because Raj showed it. You can do a lot of things using frameworks and other things, right? But the point being, you have to ingest large volumes of data. You have to be able to instantiate really powerful servers and GPUs using a simple API, right? And after that, you should be able to integrate it with Elasticsearch. You have to do a lot of analytics on top of it, right? So the entire Amazon computing platform is a powerful stack, and we just covered only the machine learning part of it. But the message is it's all tightly integrated with all the services, including, we can talk a lot about security and compliance. We have a panel. I'll be speaking at the panel. We can talk about HIPAA or whatever questions you might have and objections might have, right? So the point being, AWS machine learning stack is really powerful, and it is part of a platform which is really scalable and secure. So that's the reason, again, more machine learning happens on AWS. As you can see, though we support a lot of frameworks, TensorFlow is the most widely adopted framework, and 85% of the TensorFlow workloads that runs on the cloud runs on AWS. And we have more than 10,000 plus customers. When I say that, I want to be very clear, right? We have more than probably close to 1.5 million active customers today, and much more. This is 10,000 customers or customers using our AWS machine learning stack alone, right? So that is one. And we have customer references. And this has a lot of logos of both commercial and public sector customers. I missed Balaji's email here, but if you have any yeah. So if you have any questions, we'll be in the booth. And I really rate the success of any session based on the questions I get. So if I don't get any questions, then probably we did a great job or we did a poor job. So I would really welcome you to ask all kinds of questions. We'll be in the booth. We have a booth near the panel discussion room. We'll be here today and tomorrow. Please stop by and come up with use cases where we can really dive deep and try to understand and help you build your application. Thank you all.